Okay, this is AP Calculus AB. This is our indefinite integration using U substitution, but sometimes you're going to need to do this a little bit differently. And I'm not only going to show you how to do this differently, but also what would be your clue that you need to do this differently. So we've talked about this before, and we've said that if we look at the indefinite integral of f of g of x times g prime at x, then we can assume that we have f of u du, and from there we can integrate. So having said that, remember the first thing we're going to do when we look at something like this, first off we have an indefinite integral here, is we're going to look at this inside piece and ask ourselves, is this piece here, do we think that this piece right here might be the derivative of the inside here? And if we do, then we start with our U substitution. But here we know that the derivative of x plus 2 has absolutely nothing to do with x. So from there, we're going to do this. We're going to start down the same path that we usually use, and we're going to use a let's say, and we're going to say let u equal x plus 2. And we're going to solve for we're going to solve for du dx. We're going to solve for the derivative, and of course the derivative of this thing is 1, isn't it? The derivative of x plus 2 is 1. So we know that du, all I'm doing now is multiplying both sides by dx, that du is dx. So let's see where that takes us. So we're going to rewrite our integral here, and this x is this one. And then we have here, we have the square root, right? Square root of x plus 2. But remember, u is x plus u, so there's our u. We can replace this dx because dx is du. And remember, the form we're trying to get to is f of u du. Right, we're trying to get to this, and we almost have it, don't we? Except for this. So what this is really supposed to remind us of is that we're supposed to look in and realize that the integrand contains a factor of x. So we also have to solve for x in terms of u. What does that mean? Well, we have u here, we have u du here, that's good, but we have x here, and it's not a part of the derivative. So all I'm going to do is I'm going to go back to this, and I'm going to solve for x. So what does x equal? Well, I'm going to subtract 2 from both sides, and we can get that x is equal to u minus 2. Look what that gives us. Just going to rewrite again. Here's our integrand, and we're going to get u minus 2, because we know that x is equal to that, right? Here it is. We solved algebraically, and we got x is equal to u minus 2. Here's our square root of u. Remember that square root is exactly the same as saying u to the 1/2 power du. From here, we finally are going to get to what we wanted, and we're just going to distribute to here, and then we're going to be able to integrate, which would look like this. So after we do our distribution, we're going to get, remember this is u to the 2/2, right? And when we, remember that rule? X to the m times x to the n is x to the m plus, and so we're going to add the exponential values. So 1/2 plus 1 is 3/2, so we get u to the 3/2 minus, well, 2 times u to the 1/2 is u to the 1/2 du. This is exactly what we wanted. We have this form now. So from here, now we can go ahead and integrate. So we'll go ahead and integrate here and be done. Oh, we're going to integrate and then we're going to have to resubstitute, right? So we're going to start to do this, and we're going to go ahead and integrate now. So this would be u to the 5/2 over 5/2, right? Because remember, we're doing x to the n plus 1 over n plus 1 is how we would integrate this. This minus side is this one, and this would be u to the 3/2, right? So to the 3/2 here over 3/2 plus c. If you're taking the AP exam, they're going to ask you to clean this up a bit, so remember that this is a complex fraction, so this thing comes up as its reciprocal. So 5/2 comes up as 2/5 u to the 5/2 plus, minus u to the 3/2, or this thing's going to come up also, it's going to come up as 2/3, right? 3/2 comes up as 2/3 u to the 3/2 plus c, and that might be your answer, or you could always resubstitute. And if you remember that in the very beginning of our problem today, that u is equal to x plus 2. So you would go back and you would plug those values in here. Right? So this would be x plus 2 here. This would be x plus 2 here plus c. And this would be our final answer. All right? If you are taking the AP exam, if you're on the multiple choice part, of course, they're going to just to mess with you. They're going to make you see what the greatest thing you can factor out of here would be. You can factor out a 2 here and go from there. So hope the video is really helpful. Again, remember that you are going to have the opportunity to see this special change of variable situation. And what you're really going to be looking for is when you look here and realize that the integrand contains a factor here that is not part of the derivative of the inside. So I hope this is helpful. I'm going to do maybe 3 or 4 more of these. And you're going to get an opportunity, I promise you, to see them in Calculus 1, but you are definitely going to see them on the AP AB exam. And you're going to have to really know when to look for this stuff. So I hope this has been helpful to you. Let me know. And give me a comment. Follow me on Twitter at @CLindelof. And please subscribe to my channel. You're the greatest.